Here's a problem that you could be asked to simplify. If you did see this one, it would probably be on the first 5 problems of the GED that don't have the calculator. And so you would need to know how to simplify this by hand. First of all, let's read it. This little index here, the number 3 inside of the radical, this is a radical, tells us that this is a cube root, So a lot of people are familiar with square roots. Like, for example, the square root of 16 is 4. Why? Because square roots are the inverse or opposites of squaring something. So if I were to take 4, that number, and square it, I would get 16. What square root does is it takes you back from the perfect square to its root. So the square root of what would have been the answer when I square 16 is 4. The idea here is I'm saying on a square root, what number times itself equals 16? And we know 4 times itself equals 16. And so here, when I'm looking at a cube root, I'm asking what number times itself 3 times. Now, not times 3, that's not what I'm saying. So what number times itself 3 times equals 27? Or another way to say that, what number cubed equals 27? So again, we're going to work backwards in order to do a cube root. We're going to think about our perfect cubes. 1 cubed, 1 times 1 times 1 would be 1. 2 cubed, 2 times 2 times 2 would be 8. 3 cubed, or 3 times 3 times 3 would be 27. And so I can see that the cube root of 27, or the perfect cube that 27 is made out of, is 3. Great. If you have any questions, drop them down below, and I'm in the comments. And if you don't know your perfect cubes, I have an alternate method for this one up on the YouTube channel. Go ahead and check that out as well.